Where are we? There we are. Hey. Okay, so I just wanted to log on to see if anybody needed help with the Exam 3 review. Just in case we don't have too many. It looks like we have people on right now. But I had a couple of ideas of stuff I wanted to talk about already. If you don't have any specific questions, then I'll just talk for a little while. If you do have questions over anything in particular, I'll be more than happy to answer all of those. But I have like an hour to just hang out and answer questions and get you ready for this test tomorrow. So before we get started with the actual material, remember key things to note. One is you have to turn it into Blackboard and the Google Classroom. So I can't give any extensions on like getting Blackboard open or getting your password from Lee College or anything like that. All of you have to do it on time this time. That is something that Lee College is actually actively monitoring to make sure we're using Blackboard, which y'all know usually we don't use it that much during the semester, but we do have to use it. Your homework's closed tomorrow night, 11:59, same time, same due time as your test. Hopefully you're not juggling both of those at the same time, but based on what I've seen so far, it seems like some of you will be, which is okay. As long as you get it done eventually. I mean, I'm not your dad. I'm not going to tell you how to manage your time, but you should try to get it done when you can. All right. So I guess let me open up the floor. There's a handful of you on right now. Does anyone have any questions over any specific problem? It can be the review or it can be a homework problem. We did answer a couple of homework questions this morning on the stream, so you can always check out that video if you would like. But other than that, any questions from the chat? Hey Damien, how's it going, bud? Alright, 6-4, number 27. Let's pull that one up. So this is a new one. We have not covered this one yet on stream. So this is Introduction to Vectors. So you have a river flowing southward. You have a current of 7 miles per hour. A motorboat in still water maintains a speed of 17 miles per hour. The motorboat starts at the west shore on a bearing of north 38 degrees east. What is the actual speed and direction of the boat? So the visualization here is that you have a boat trying to go northeast, and then the river is pulling it south. So you've got a vector like this, and you've got a vector like this. So you need to add the two vectors together and figure out the actual speed and direction. And then the direction is going to be part B of this problem. It says do not round until the final answer because you have decimals involved. So, and I see all of your posts on the review question, so let's do this one homework and then we'll do that. So, whoa, I don't want to design. Hold on. Hello. Okay, so let's label this. So 6-4, number 27. Alright, so you've got a river flowing southward, and that was 7 miles per hour. The unit's going to be miles per hour for everything. We don't have to label it here. Okay, so 7 miles per hour, and then the boat wants to go 17 miles per hour north 38 degrees east. So the way you read that bearing is you start facing north. So there's north. Turn 38 degrees towards the east. So that's 38 right there. Towards the east side. And then that's a magnitude of 17. So I'm trying to add this vector and that vector together. Okay. Now remember, you have a couple of ways that this can help you, or that can help you get this together. One is I would draw the vectors together so you see what the sum looks like. Usually this amounts to drawing a triangle, and then you'll want to use some form of, law of sines, cosines. Hopefully you end up with the right triangle sometimes. This one you won't, but just use a little geometry to figure out what the actual direction is. So let's copy this angle again, or this vector again, the length of 17. So if this right here from north going east, if that's 38 degrees, then that means you could do the complement to figure out the other side. So let's see if we need it first. So here, we've got, I don't know how big 7 is going to be relative to 17, but it's not going to be a right triangle. That's the main thing here. Okay. So you've got 7 miles per hour down, 17 miles per hour going, hold on, y'all's camera's reversed, going this way. I got to do it backwards for me. So the result is going to be from the beginning of the first one to the end of the second one, right there. Which is going to have a direction of some kind. Wow, what is going on? Hold on one second. My chickens in my backyard are going crazy. Okay. Okay, so we need to figure out the magnitude of this vector, right? Wait, is this the one that they designed to be? No, they didn't, right? Yeah, south 7 miles per hour. Then if it's still water, you're going 17 miles per hour northeast. Okay, hold on, y'all. Sorry, this is kind of... I wouldn't interrupt the stream normally for this, but they're going kind of nuts. Hold on. Alright, got my kids to do it. So we are missing a relevant piece of information here. We know we're going straight south. We know it goes northeast to north 38 degrees east 17. It's definitely not a right triangle. Huh. Well, let's see what they say. Yada yada. Measured from north, you actually have the real direction, yada yada. Okay, so we did this already. So with their view and example, this little, can y'all see my, hold on, mouse cursor, here you go. So that's the river flowing south. That's the northeast one. You know, they have different numbers for this one. And then so our result, the result is the river is going to pull it down a little bit. We know that much. What is our other relevant piece of information? Yeah. So they just broke up. Wait, is it 21 for this one, the boat? Yeah. Yeah, so it has an x and y component. Yeah, so we're just going to add the x and y components together. Okay. Alright, that's what they wanted us to do on this one. So I guess the picture is not going to be super relevant here until later. Okay, so we'll call this R for river and B for boat. There we go. So the river, it has an x and y component. Well, it doesn't have any x component, so 0i. Oh, I wrote behind my overlay again, I'm sorry. And then minus 7j. The boat... Now it has an x and y component, so we need to break this up into the x and y component. So use that 38 degrees. We've got to figure out how much of the vector does this and how much of the vector does this. So the adjacent side would be the y component for 38. So 17 cosine 38 would give us the y component. So let's do sine for the x component first. Turn on. 17 times sine 38. So the x component is 10, and they said not to round, so 10.466. We'll make a note to ourselves that we shouldn't round. I. And then the j should be plus, so we can write a plus here. Same thing with cosine. $13.396, blah, blah, blah. Sorry, so the r is behind my overlay a little bit. But you have to add r and b together and then do Pythagorean theorem to figure out what the magnitude's going to be. Notice how the only thing that changes is on the y component, you just take 7 away whenever you add them together. So the resultant one's going to have a y component 6.396, blah, 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 blah. And then we want to do Pythagorean theorem with those unrounded numbers. So square root of, let's make the calculator do all of this, squared plus that squared. So 12.265, so what does it want the final answer to be? 1 decimal place, so 12.3. And then we still have a part B to this question, Maddie, so the actual bearing of the boat. So we've got to find the angle of the boat. So for a random vector that is going 10 this way and 13 that way, remember, inverse tangent will give us that one, but we want to do that north facing east little bearing thing. So we've got 10.4 blah, blah, blah this way. We've got 7 point whatever blah, blah, blah going this way, or 6.396 blah, blah, blah going this way. And then so we'll do inverse tangent. That finds that little angle, and then we want that angle, so we can just do 90 minus whatever our calculator tells us. So inverse tangent of that opposite divided by adjacent, that 10-point thing. So that's the little angle, the purple angle. And then we want to find the complement. And so 58 point, and then it'll probably be 1 decimal place. 1 decimal place. So north, 58.6 east. Oh, come on. Start typing. There. Okay. I guess I should write those numbers here. So 31.43. This one is 90 minus 31.43. And we ended up with 58.6. I didn't actually write the answer from earlier, did I? 12.3. There we go. Sorry, that's really sloppy. But hopefully you're watching the video where you're logged on right now. Okay, moving on. So we have a lot of review questions in chat. Were there any other homework questions y'all wanted to get? You wanted me to get to before I did that? All right, let's start working on this review. Let's get a 0 on this test real quick. Yeah. Oh no, I fail. All right, number 5. Oh, we have done this one, I think, 3 times on stream at this point. I have helped a lot of people do this one already. So just to save a little time, I'm only going to set it up. If you want the full workout solution with every line of work, the post for this was April 9th. If you want to go back there, I believe. April 8th or April 9th, something like that. So we worked this problem beginning to end. We've done it twice now on the stream and one time off record. So I will set it up for you. So review number 5. Because this is identical to the homework question you got. Just different numbers. So the tower is 700 meters high. Oh. So we'll call this T for tower, 700 meters high. So the base of the building is the same plane as the base of the tower. So it tells you it's a right triangle because they're both level with each other. And then you have an angle of elevation to the top and an angle of depression to the bottom. So the building is somewhere here, and you don't know how far away the building is. But the angle of elevation to the top, remember that's relative to horizontal, and then you've got an angle of depression to the bottom. So the elevation one is 75.24. The angle of depression, 60.05. And then the question is, how high would the building have to be? So X right there. The key, there's 2 main keys to understanding how to even begin this problem. One is that if the height of the building is X, then right here, if you go straight across, this height is also X. Because they're on the same plane, they're the same height. Which means this height right here is 700 minus X, because you have to take away the height of the building. So when you do that, notice how you've created 2 right triangles. You've created the top one right here, and you've created the bottom one right here. Now, they both share the same side. They both share the distance from the tower to the building, which you don't know, right? D for distance, whatever. Call it whatever you want. It's not going to matter whenever we solve the problem. So if I just look at the top triangle, then you can do tangent 75.24 equals opposite, which is 700 minus X, over adjacent, which is that distance to the building. For the lower triangle, you do something similar. Tangent 60.05 equals opposite, which is X, divided by adjacent, which is D. And this is a system of equations. You have 2 equations and 2 variables. You want X to still be in the problem at the end, so you have to substitute in for D. So if I take the second equation and switch D and tangent, D equals X over tangent 60.05. And you can substitute this in right there. You combine them, you create an equation that only has X's in it, solve for X. It's just a lot of algebra. It's not even a quadratic, it's just a linear problem at that point. So you should be able to solve for X from there. So sub, and then solve for X. Okay. So like I said, we've done this multiple times on the stream, but that is how you set up the problem. As soon as you do that substitution, it should just be a bunch of rewriting some stuff around and solve for X. Again, it's a linear, it's not even quadratic, so you just get the X's on the same side, factor it out, you should get the answer. Okay. Damien, 10, and we'll go 14, 15. So 10 next. All right, let me make sure. Okay. Flagpole 94.4 feet tall is on top of a building. From a point on level ground, the angle of elevation to the top. That's bad English. The angle of elevation to the top of the flagpole is 35.1, while the angle of elevation to the bottom of the flagpole is 25.8. Find the height of the building. And I could see why you have, yeah, it's the exact same question, Damien. So you've got 2 different triangles. You'll do tangent for both of them. And then the distance from the person to the building is your D, is your width, and it's going to get subbed in for, and you're going to do literally the exact same thing. So don't feel bad for asking the question. I mean, if you didn't know how to do 5, you wouldn't have known how to do 10. But it is the same question. Okay. Okay. Let's do 14. It comes next in order, right? Oh yeah, I'm not going to do this to you on the test. They just wanted you to keep the square root in this problem, which I think is dumb on triangle problems, because no contractor is ever going to go out and buy lumber for a project and let's see, I think I need exactly 35 square to 3/4 square units. Oh, that's stupid. So anyways, I will not be making you do that on the test, but for this one you have to keep it in radicals. Find the exact value of the area of the SAS triangle. So area means Heron's formula, right? Because this is not a right triangle. Yeah. Oh, I see why, because it's in the law of sines section. So you do law of cosines for this. So once you find side C using law of cosines, then you can just directly apply the law of cosines. So number 14. Okay. So you've got C equal to 120. A is 7, B equals 5, and we want the area of the SAS triangle. So we need to find little c. So c squared equals a squared plus b squared minus 2ab times cosine of c. So this is the square root of 49 plus 25 minus 2 times 7 times 5 times cosine of 120 degrees, which ends up being negative 1/2. Right, that's a unit circle number. So all variations of this problem, they'll give you a unit circle number for this one. So you actually end up getting square root, what is this? 2 times 7 times 5. So this is... Okay, well cosine 120 is negative 1/2, so you have a negative 2, negative 1/2, that just changes it to a positive. So we're adding 35 to this. So that's 60 square root of 109. I guess we're doing this on an actual test review. Let's make sure I'm not screwing up any mental math. Doesn't take too long to type, right? 7 and 5. 2 times 7 times 5 times cosine 120. Yep. So c is the square root of 109. So you got a, you got b, you got c. You can do Heron's formula here. It's just going to be annoying because we're going to have to reduce a bunch. But s is 12 plus square root of 109 divided by 3. Whoa, that looks awful. All right. And yeah, I don't know why. I'm sorry I gave this to y'all in the review. I would never make you keep the radical in this problem. This is ridiculous. Square root of s times s minus a times s minus b times s minus c. This is so annoying, I'm not even going to do it. If you just have the decimal, it's just typing into the calculator and getting the answer. The whole reason it all reduces down to square root of 3 is because after all the distributing, the whatever's in the square root is going to reduce. But I'm just going to say just use decimals. If you go back to that particular homework problem, I guess you can look up the view and example if you really want to, if you really want to know the method they use, but it's just a crap ton of distributing, that's all. Okay, let's go to 15. Two hikers, Sonia and Tony, leave the same point at the same time. So you've got two vectors here being involved, or not we haven't learned the vectors yet, quote unquote, in 6.3. But you've got two sides of a triangle. How far apart are the hikers after 4 hours? So 4 hours, so that means that you have to multiply both of those lengths by 4. Maybe that might have been where you screwed up. But, so let's see. So number 15.
Daddy, I cut myself.
Aww. Sorry, buddy.
Again, I cut myself again on the same spot.
I'm sorry, buddy. You need a Band-Aid? You can sneak in to Mom's bedroom and try to get a Band-Aid.
I can't reach them.
You can't reach them. Okay, well, I'm actually recording right now. My students are watching right now, so Can I help you when we're done? Just take it easy for a little bit. Yeah, you want to say hi? They're literally just watching right now. No. Okay, come on.
Hi.
Hey. Tell them your name just in case they don't know. What's your name?
Malachi.
Malachi. How old are you?
4.
4. Yep. What are you doing?
I was playing outside.
Playing outside. Nice. Did y'all check on the chickens for me? What was wrong?
Nothing. I
Nothing.
gave them some food.
Oh, okay. Well, that's nice. Cool. Alright. See you, bud. Okay. Alright. Let's see. Sonia's walking due east. So, if we're going to represent Sonia like this, 4 hours, 6 miles per hour, so she's traveled 24 miles. And then Tony, 45 degrees northeast. So 3.2 for 4 hours, so 12.8. Why is Tony so much slower? Come on, Tony. So how far apart are the hikers? So this is 45 degrees. And then there's your unknown. This is actually just directly law of cosines. Okay. The wording of the word problem might have gotten some people thrown off here, because this is not the first time someone asked me to do 15. But once you see it drawn out, you see how it's a triangle. It's a side angle, side triangle. So if we just do law of cosines here, 24 squared plus 12.8 squared minus 2 times 24 times 12.8 times cosine 45. And just plugging that in should give you the answer. I mean, the answer should be, what, 17.5? Let's make sure we get that. Yeah, 17.5. So we got the correct answer. Oh, yeah. Because all of the length should be just in miles. So if you multiply it afterwards with 4 hours, then it wouldn't have been right. Because if you try to visualize it, after 1 hour, it would have been 6 and... Hold on, I got to do this backwards. 6 and 3.2, right, which is a little shorter. So you could get that distance right now, but as these grow out longer, this is getting more than 4 times as long. So not all sides scale linearly whenever you have an unknown. Okay. That actually covers most of what I wanted to talk about in the first half of the test review anyway, so I'm kind of glad you asked those, Damien. Oh, look, we actually have like 9 people. It's because it's not 8 a.m. and people are actually awake, right? I know y'all are missing out on the morning Twitch drops. I've been handing out 5 extra credit points on homeworks. I'm not going to be doing that for this stream, by the way. So, I don't know. Maybe y'all can talk me into it. 16. Yes, I can. I'll use the vectors to graph the following vector. So, I guess I'll just try to show this one to you. Drawing this one would be kind of rough on the PowerPoint, but let's pop this out. Okay, 2v plus u minus 3v. So what you want to do is draw them all in order, and then whenever you draw the next one down the row, make sure the beginning of the second one starts at the end of the first one. So 2v just goes to the right by 4 units. Here, we'll go ahead and try to draw it. Hold on. Gotta make another couple of slides here. Okay. Okay, so let's see, gotta look up. 2v goes to the right, and it's 2v, so it's twice as much, so it goes to the right by 4 units. There's v. And then plus u. U actually goes, what, down by 2 and over by 4 in this problem. So here, down by 2, over by 4. Here's u. Minus 3w. So w goes up 2 over 1. It's 3 times that. So we're going to go up 6 over 3. And then it's negative, so we're going to reverse that. So we're going to go down 6, left 3. Oh, I did not give myself enough room for that. Ah, shoot. Let me just redo this. Whee. Okay, so there's 4. That's 2u, 2v. Then u, oh, that's down 2, or 4. And then minus 3w is down 6, left 3. So down 6, left 3. So your result is going to be from the beginning of 2v to the end of that negative 3w. So your answer starts here and ends there. Now you can actually count spaces if you want to know the coordinate point. Remember, you can slide vectors around as much as you can. The key here is you went, let's see, right 4, and left 3. So that means you went this way a total distance of 5 from your original starting point. And then you went down 2 and down 6, so you went down 8 a total from the original starting point. So you have the components of the vector if you actually want to be really picky, really specific about it. So you need to pick the one that goes down 8 over 5. So that's why D is the answer. You see how the arrowhead points out down and to the right? So it's going the proper direction. Okay. This bothers me so much on my tags on my stream, how it just says English and educational game, and I can't really, I mean, I could change it to a game, it's just that it doesn't let you just put in your own category. So I can't put, hey, I'm a math teacher. I'm just doing like, there is a game being played where I teach things, I guess. All right, are there any other questions, specific ones? I had a couple I was going to just talk about. I didn't have any other ones I planned on solving beginning to end. Yes, all right, 26, 28, 38. Let's do it. Let's add a few more slides. All right, pull up this test review. 26. Okay, so you have V and you have W. Find the angle between V and W. So this is actually your formula for dot product. You could have tried to draw them into geometry, but dot product's going to be easier here. So review number 26. Wow, that's a bad 6. Hold on, what? 26. Good enough. Okay. So you've got V is 5i plus 4j. W is 6i minus j. And you want to find the angle between them. Well, remember, V dot W is magnitude of V times magnitude of W times the cosine of the angle between them. So the theta is the only thing that you don't know in the problem, because you can find V dot W. So remember, to dot product two vectors, you multiply the x's, you multiply the y's, and then you add them together. So V dot W is actually just going to be 30 minus 4. Right, 5 times 6, 30. 4 times negative 1, negative 4. And the magnitude of V, you got to do Pythagorean theorem. Do they want exact here? No, round. Okay. So up here, let's just do magnitudes. You just want to do Pythagorean theorem of 4 and 5. This is not a 3, 4, 5 triangle. 4 and 5 are the side lengths. Also, we want decimals. So 6.4. And then this one is 6 and negative 1. Well, the negative won't matter because they're squaring. 6.1. So 6.4 times 6.1 times cosine theta. So 26 equals those two things times cosine theta. What you end up with is cosine theta equals 26 divided by whatever that product is. All right, I guess let's get an exact one. 38.95. Blah, blah, blah. Decimal goes on forever. Inverse cosine both sides. So inverse cosine, 26 divided by that mess. You get 48.1. That should be the answer they gave us on the, yeah. So this is going to be a very important formula for the second half of the test for 6.5 and 6.6. Well, I mean, not half, but no, the last third of the test. There you go. No, you don't even use it in the polar section. Whatever. For 6.5, it is going to be a very important part. Okay, let's hop over to 28. Let V and W be two vectors, have magnitudes 4 and 6. The angle between them 60. Find magnitude of 2V plus W. Okay, so this is similar. You have to use that formula that we just used. So 2V is going to have a magnitude of 8, right? You already have the angle. So, yeah, I mean, this is pretty similar to what we just did. I guess it's not as, never mind, now that I'm thinking about the steps of work. You probably have to use the definition of the magnitude to get there. Here, let's pull up the, let's see, I should have it just in my downloads folder. Where is that? 6.5 notes, yeah. Let's pull that up real quick. Okay, so as far as all the different ways you can define the magnitude, sorry. Oh, I guess that's not really going to apply here. Hold on. I mean, I'm trying to think of another way to explain this problem besides the law of cosines way that I showed you. Because this exact question is this one. Right? This is the exact same question, just with different numbers. I guess I'll point you to this one in order to figure it out. But the key here is that I just draw a triangle and then do law of cosines to figure out the magnitude. You can actually use the definition you can actually use these to figure it out, but I think the law of cosines way is easier to explain. But just take a look at the 6.5 notes. I'll leave this up for a little bit. But so the V plus 2W, whatever your 2 is in this problem, it was the first one. So you've got an arrow of 8 and an arrow of 6. Angle between them is 60, so slide one over, draw a triangle. And then law of cosines actually finds you the answer. And again, I'm not going to make you do exact radicals on something like this. I do make you do exact radicals on a couple of things on the test, but they are not going to be so convoluted that you have to simplify a huge radical or doing that. I mean, it should just be very obvious when you need it, and the radicals should not be that bad. Okay. Oh, one thing I forgot to mention. There is a bonus question on the test. I decided to do it as I was revising the questions on the test. And there is a bonus question. I will not be answering any help questions on it. I think it's pretty, for those of you that are going to attempt it, it's pretty self-explanatory. But yeah, I think those of you that try it, you'll like it. All right, 38. All right. Oh, polar to rectangular. So r is 14 sine theta. Wait, I say? I already forgot. 14's, I think, yeah. This is really similar to the last one we did in the notes, the literal very last slide we did in the notes. The trick here is to multiply both sides by r. So whoa, that's an r. R squared is 14r sine theta. So now you can plug in things because you have a thing to plug in here, thing to substitute here. X squared plus y squared equals 14y. And technically this is it. Like this is rectangular form. You could be done. The reason why the answer doesn't look that way is because they went ahead and completed the square. So you got x squared plus y squared. They subtract the 14y over. And then the way you would complete the square, half of the b term squared. So you'd add 49 to both sides. So you got x squared plus y minus 7 squared equals 49. So a circle with a center at 0, 7 and a radius of 7. Okay. And that's just going back to college algebra days. All right. So we went beginning to end. I think we actually might have covered everything I wanted to cover. We talked about some of the 6.3 stuff, right? 6.4 stuff. Some of this is just directly using some of the definitions. Just remember, vectors make triangles, so you can do all your triangle stuff. Just remember that one formula we talked about, this one. I mean, not that you have to make a note card, but you want to have it handy as you do the test. There are 6 questions on the test that correspond to the 6 sections of the book. There's a bonus 7th question, and you might be thinking, oh, wait a minute, only 6 questions. But some of them have parts A and B, where each of them are worth 10 points. So there's still 100 points to distribute on the test. So it's still, I should have numbered them differently probably, but it's still 10 problems worth of stuff to do. It's just numbered 1 through 6. So just treat the parts A and B that are 10 points each, just treat them like separate problems. The PDF will go live 8 a.m. tomorrow. Do exactly what you did before. And then we'll talk about this on Thursday or Friday's stream, but your final exam is actually going to be on my math lab. So be sure you pay attention. I'm going to give you details on that. You did? You got a Band-Aid? Oh, good job, buddy. Yeah, I'm still talking to my students. I am live right now.
Hi.
You gonna tell them your name? Most of them don't know all your names.
Asher.
His name is Asher. Asher, how old are you?
6.
6? Yeah. What did you do in school this morning?
I did research and I did multiplication.
Multiplication, that's right. We did our 3s and our 5s this morning. You did your 6s last time?
Yeah.
We've done all of them, but we practiced our 3s and 5s, right? Okay, let me finish up my stream. I'm almost done, okay? You can tell them bye.
Bye.
I'll be done soon, but okay? Okay, go. Alright, let's see. Oh, look, we get a teacher appreciation day. We get to go up to the school and pick up breakfast? What is this? Oh, yay. Huh. Nice thought, I guess. I'm not sure I'm going to do that, but I do live 40 minutes away. Were there any other questions that came up on the test review? I think we've covered a good bit of material. We've been going 45 minutes now. But I guess just pieces of advice. Just remember, try not to leave anything blank. Write all relevant work. I mean, it's a take-home test. Look up what you need to. Do what you need to. I understand all the implications of that. Just be sure your paper that you turn in is your own work that you can you know, justify, defend, I don't know what to call it. Not that any of you on exam 2 had any issues whatsoever, but my high school class, we had a couple of issues with some tests. So y'all are college students. Y'all know not to do that stuff. I guess I don't really have anything else to talk about. Do y'all have anything else for me? I am extremely tired. This is my nap time. Y'all are intruding on my nap time. It's been so nice taking a nap during the week now. Oh, it's glorious. They should have that as a class next year at school. Pre-AP nap time. Alright, if there's no other questions, I guess we'll call it a day. Stay tuned. Post your tests to Blackboard and the Google Classroom tomorrow. And do your My Math Lab homework. And I will see y'all tomorrow. Bye.